Right, hi everyone. So, another video. This is on numerical methods this time. Again, it's kind of like functions in the sense that it's love it or hate it. The actual maths itself is quite simple, relatively speaking, and potentially quite interesting if you're really into maths. So, let's see where we're starting here. So you can see here, we've got f of x equals x cubed plus 4x squared minus 5x minus 2. If we want to find the roots of where f of x equals 0, so i.e., remember this is a simultaneous equation where this thing crosses the x-axis. That's what f of x equals 0 means. But we've got nothing to start with here, have we? I mean, in C2 it was easy because we'd get given a factor, let's say, we'd use the factor theorem. We'd try f of 1 or 2 or 3, and it might equal 0, or we try f of 0, or we try minus 1, minus 2, minus 3. But the point is that most cubics do not have neat integer values in their x-coordinate. Most have some really horrible root, and that's what we're going to try and find here, the horrible roots. That's what numerical methods is all about. What you start to learn is that in the real world, we don't have all these neat e's and pi's as answers. You know, a lot of the times, especially engineering and stuff where you want to just get things done. You know, numerical methods is all about trying to get the most accurate answer you can with, I suppose it's the most accurate answer you can that's worth it. You know, you don't need an exact answer all the time. Okay, how do we do that then? Well, I'm going to show you kind of the method, and then in class we can talk about how it works. The method would be, we're looking at when f of x equals 0. So when this is f of x, and this does equal 0. There are certain ways that we can rearrange this formula. I mean, how many roots are we expecting? How many roots are there? Well, as it's x cubed is our highest order, we know that there's potentially 3. Yeah? Potentially 3. So I'm going to try and rearrange this equation and see what happens. I could rearrange it a couple of ways, couldn't I? I could make x the subject here. So I'm going to try and my objective is to make x the subject. So x could be the subject like this. It's a fifth of that whole thing. That's one way of making x the subject, yeah. Another way, well, I could make x squared the subject and then square root everything. So I've got 5x minus x cubed plus 2. That's my 4x squared, isn't it? Divide everything by 4. And then square root everything. Could have the plus and minus, but let's assume a positive root. Don't know. That's another way of rearranging it. Another way, I could cube root everything. So move everything over to the right. X squared plus 2, and then cube root it all, right? That's another way of making x equals. Now, I'm going to try something with you. Get your calculators out. I want you to, let's focus on this third iteration here. This one. I want you to put in x equals minus 1. So I want you to do this with me. So press minus 1 on your calculator and press equals. Then go cube root 5 answer, you know that answer button trick, minus 4 answer squared plus 2, and then press equals once. You should get minus 1.9129311183. Press equals again straight away. So you get minus 2.810584038. Keep pressing equals. Equals. And if you just keep pressing it, you see the numbers are changing, but not by much. Not by much at all. It starts converging to what looks like minus 4.931498, you know? So it starts looking like minus 4.9316. So minus 4.93 definitely looks like a solution. If I whack in this curve, y equals, what do we have? We had y equals x cubed plus 4x squared minus 5x minus 2. There we go. And look, one of the roots is absolutely near minus 5. That looks exactly like minus 4.93 to me. Look at that. How did that work? How did that work? Well, hopefully you're curious enough to find out why that works. And we are going to find out in class, okay? Because I think it's worth going over in class, and hopefully you've whetted your appetite on why that works. So, let's see that done again, but with a different example. So at the moment I'm just showing you kind of what can be done, and then I'll show you the exact way of how to do it, because that calculator trick, can you see what we did there? Actually, well, no, we'll explain it in class. But just to take this one step further, what I did there was I turned this. If I wrote it like that, can you see that this looks like what's called a recurrence relation, which you did in C1? You did this in C1. I chose a value minus 1, that's x0, and it came out with a new value. You whacked in x0 in there, didn't you? It came out with a new value, which we'll call x1. You then pressed equals again, so in a sense you put that number in, and it gave you x2, and you kept going until like x100 or something, and then you got minus 4.93 roughly. How does it work? Why does it work? Find out more. Let's try again. This time we've got 2x squared minus 5x equals x squared, take 1, take x, take 1. We can't do anything with this. We're trying to find the roots of this. Obviously, we could solve this, couldn't we? We could just move everything over to the left. So I get x squared, that goes on over there, minus x, so minus 5x plus x, that's minus 4x, and then we got plus 1 equals 0. I could solve when that thing equals 0. But let's pretend we can't. Let's pretend we can't, and let's see how this numerical methods thing works. Again, how many roots am I expecting? Well, I'm expecting 2 roots, because it's an x squared there. If I don't have any roots, then that means the quadratic doesn't cross the x-axis. So, I rearrange x squared equals 4x take 1, and I could square root it. 4x take 1. That's one reiteration, and in your exam this is exactly what they're going to ask you to do, to rearrange something. Or I could get x squared plus 1 equals 4x, and then divide by 4. That's another way of rearranging it to make x the subject, isn't it? And likewise, I could make this an n plus 1 and an n plus 1 and an n, and I need a starting value to start solving this thing. What starting values should we use? Well, what if we tried something like x equals 0.1? No, that's not going to work. Let's say x equals 1 in there. Let's try that. So calculator, press 1. So this is my starting value. x0 equals 1. Just press 1 equals, and then square root 4, answer minus 1, get root 3. Just press equals again. Equals, equals, keep pressing equals. Blah, 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 blah. Keep pressing equals. And look, 3.73 keeps converging. And I bet that's the solution. If I whack that in the graph, I bet that's the solution. Now, hopefully, you're starting to ask, so just to be clear, if you had a situation like that, you're going to move it all over to the left. We did it, that's an easy example. And I'm showing you that numerical methods will find the root if you rearrange to make x the subject, and then you put in an appropriate starting value. And that's what we would talk about in class in terms of the theory. Like, why does it work? You don't need to know why it works, but it's interesting why it works, and it starts to put stuff together. You start making links, okay? Hopefully you're thinking to yourself, well, when, like, how do I know what that starting value's got to be? How do I know that? Well, looking at this previous example, first off, if we can show that there are roots lying between these numbers, then we can start to use that method. We can rearrange and say, well, between that interval, x must lie between there, and then we can whack it into our recurrence relation, which I just did, and then I found that root. If I put in a different number into that previous one, so let's say I tried x equals minus 1, I would get minus 4, minus 1 square rooted, which you can't do. You get a math error. It would be an inappropriate number to put in. So, the question's saying show that the roots lie in the interval 0, 1 and 3, 4. So let's go from where we were before. We were here. We moved everything over to the left. So we get x squared minus 4x plus 1 equals 0. This is the new bit. So you're always going to write let f of x equal x squared minus 4x plus 1. Let's remember what we're trying to do. We are trying to find when this graph crosses the x-axis, where its roots are. That means that at some point, I don't know where, well I do know because we did it in the previous example, it's somewhere around 3 point something. It means that this has a positive y value, doesn't it, between here, and here has a negative y value between here and here. That's negative y, and between anything above, that's a positive y value, right? So the theory is, if I can show that on the left-hand side, here, I've got a positive value of y, and on the right-hand side of this root, I've got a negative value. Since the y has changed in sign, there must be a root in between. There must be something in between, all right? Unless, for example, you have a 1 over x graph, which is like this. If you picked a point here and you picked a point here, you would say that, oh, the value of y has changed place, and therefore the graph must cross somewhere between here and here. But that's not true, is it? You've got an asymptote here. The graph doesn't cross here at all. So this is a not continuous graph. This method will only work if the graph is continuous. It must be continuous. So f of x must be continuous for this to work. Okay, so let's see what we're doing then. So f of x equals x squared minus 4x plus 1. I've got an interval here of 0 and 1. So interval 0 and 1. So that means that f of 0 equals, you must write down the insertion of this value again. So if f of 0 is 0 squared minus 4 is still 0 plus 1, so that's 1. So this is positive. So we're saying when x is 0, we have a positive y value. If I now whack in f of 1, 1 squared minus 4 times 1 plus 1, so that's 2 minus 4 is minus 2, which is less than 0. Hurrah! There is a change in sign. So let me reiterate again. You got some quadratic when x is 1. When x is 0, you get a positive value of y, which is 1. When x is 1, you get a negative value, minus 2. So if the graph is connected, somewhere between here and here is a root. Bingo. And therefore, it must lie in that interval. So change in sign, and f of x is continuous. And that's important because that links to our 1 over x graph. So change in sign and f of x is continuous, therefore root in interval. So we've located that there's a root there, and then we can use a previous method to find where that root is. Part B, we can also prove that our suspected root of 3.73 is correct to 2dp using this method. Because what we can do is we choose the interval 3.73. If x equals 3.73 is right to 2dp, then just either side of 3.73, so let's say here's 3.73, just either side of it, i.e. its upper and lower bounds, so 3.735 and 3.725, the y must change in sign here as well because it crosses at that point. Do you see? So choose interval, the upper and lower bounds, 3.725, 3.735. And now we can go f of 3.725 equals f of 3.735 equals, so got to write that in. Where are we? So 3.725 squared minus 4, 3.725 plus 1 equals, whack that in the calculator and write that full value down. Let's do that. So 3.725 equals, use that answer button, answer squared minus 4 answer plus 1, and I get minus 0.024375, which is greater, which is less than 0. Whereas if I put in 3.735, so write the same again, squared, you must write it, okay? You must write it. If I whack that in, 3.735, otherwise you don't get the marks. Answer squared minus 4 answer plus 1, I get 0.010225, which is greater than 0. And therefore, like before, change in sign, f of x is continuous. That's really important. Therefore, root must have a closing statement, root correct to 2dp. Wicked. So, here's an actual formal example. So we've done that one. Here's a formal example which would match very similar to an exam question. Just to bring it all together. So first off, it's saying show that this thing has a root between the interval 3, 4. So let f of x equal x cubed minus 3x squared minus 2x plus 5. Choose the interval 3, 4. F of 3 then equals 3 cubed minus 3, 3 squared minus 2, 3 plus 5 equals. F of 4 equals 4 cubed minus 3, 4 squared minus 2, 4 plus 5 equals. Let's work those out. Calculators out. 3 equals answer button cubed minus 3 answer squared minus 2 answer plus 5. That's minus 1, which is less than 0. 4 answer cubed minus 3 answer squared minus 2 answer plus 5. 13, which is greater than 0. Therefore, there must be a root in there because there's a change in sign. So therefore, this is what you would write. Change in sign. F of x is continuous. Therefore, root in interval. Okay, cool. Part 2. So show that f of x can be written as this. Okay, well, we've got to rearrange this thing. The fact that it's got a square root there instantly tells me that I need to get the square root, the squared, x squared on the right hand side. So I've got x cubed minus 2x plus 5 equals 3x squared. Divide everything by 3 equals x squared, square root it, and I should have it. So x equals the square root x cubed minus 2x plus 5 over 3. Fantastic. There we go, tick that one off. Happy with that. Part 3 then. Starting with x naught equals 1.201. Find x1, x2, x3, x4, and x5. Okay, so likely in the exam they would then give you this as the next line. They give you your recurrence relation, they give you that first value, and now you're going to your calculator and you put in 1.201 equals. You're then pressing square root. Do this with me, yeah? Answer cubed, you got to practice on that calculator. -2 answer plus 5, divide by 3. You should get 1.201432978 and equals again. So just 572845, press equals again. See, it's just gradually getting closer. And again, 201632686, and again 1.201637415. Wicked. And it says, therefore, give the approximate root to 3dp. So it looks to me that it's obvious that to 3dp, that's my root, 1.202. It says, prove that your root is correct to 3dp. So we've just done this. So we'll choose the interval, and we always go for the upper and lower bounds, 1 decimal place more than what we have. So choose the interval 12015, 12025, f of 12015, f of 12025 equals. You would need to write that in, and remember this needs to go into f, and f was this. So 1.2015 cubed minus 3, 1.2015 squared minus 2, 1.2015 plus 5. 5 in there. And here we go, 1.2015 answer cubed minus 3 answer squared minus 2 answer plus 5. So I get 0.0000681 dot 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 dot. This is greater than 0. Do the same for here. 1.2025 answer cubed minus 3 answer squared minus 2 answer plus 5 minus 0.004196 blah blah blah, less than 0. Change in sign. It's worked. Change in sign. F of x continuous, therefore root correct to 3dp. And that's numerical methods. That's the whole topic basically done. The why, we can cover that in class if you're interested, but that is exactly all you need. Be really strict on all this stuff here, okay? For that last bit, actually writing it all out, otherwise you don't get all the marks. And that's done.